Hello guys, welcome back to the channel. So in today's video, we're going to continue with our series on working with agentic systems. So in this video, we're going to go ahead and look at how to work with memories in AI agents. How do AI agents remember stuff, right? All about memory. So we're going to cover all of that. In this case, in this video, we're going to focus on only the theoretical bit of things, understanding what memory is from a context of the human perspective, and then taking that perspective and building it into AI and understanding. And then from there, the next video, we'll go ahead and actually implement some practical sections. So in this practical section, it's going to be more over just talking, right? So, okay, let's get into it. It's not going to be boring anyway. It's going to be interesting. So let's get to it. So this is the course overview. Everything you've been looking at so far. We have looked at a simple agent working with chains. We went ahead and worked with routes in the last video. Now you're looking at agent memory, right? So let's get into it. So, this is what the things that we're going to be covering in this video. We're going to be looking at what is memory, the memory in the context of a LangGraphs or agentic AI system. In this case, the context of LangGraph because the LangGraph is what you're using. But some of these concepts go ahead and apply to other frameworks and other. It's just a generic understanding, right? So understand things from a more general perspective. And then you're going to be looking at types of long-term memories in humans, or types of long-term memory in AI systems. So we look at short-term memories as well. Okay. So also go ahead and look at the times to update memory, when to update memory when working with AI systems and all that. And then finally we'll have our closing thoughts. So let's jump into it. So what is really memory? So imagine that you're chatting with a chatbot that doesn't remember anything. So you just asked it, hey, what's your name? And then it tells you its name, right? And then the next conversation you ask it, hey, what was my previous question to you? And this AI agent can't remember. That conversation will be pretty boring, right? Because the AI agent can't remember anything, right? So even the last conversation, the last message you sent it really can't recall. That conversation will be really boring. So imagine the other way around, right? We have chatbots. Let's imagine that you have a chatbot, let's say an Amazon chatbot, and this chatbot you can chat with it for different reasons, like every time you're going to purchase something on Amazon, right? So each time you come back to this bot, it actually knows you, greets you by your name, makes for you product recommendations based on your previous conversations. So it really understands you at a personal level. Such an AI system will be better to chat with than the prior one, right? So the latter is better than the previous one. So yeah, that's one of the reasons why we need AI memory in AI agents. So take it from another context, right? So you are going on you have an agent and a human conversation right here, which is just a screenshot of this conversation. And the human asks, what's on sale today? And the AI responds, hey Sarah. Sarah is the name of the person, right? So I noticed you have been interested in sustainable fashion lately, and you can see it's offering sustainable fashion deals at 20% off. So that building on the conversations of the AI agents and the AI agents learn the human over time, learns from the human over time what they prefer, what they don't like, and all that. So it stores us all that information in memory and uses all that information to make future recommendations to this a customer, right? More like a recommendation system, but now or more on a kind of a human kind of level than just an ML algorithm. Okay. So that's basically it. So memory allows AI agents to do a couple of things, like building context aware conversations. Like they don't just talk; they are talking based on context, based on previous conversations and history that they have of you. They provide increasingly personalized recommendation over time, like the one we just saw about the 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 sales, like, or the chatbot from Amazon. It can also help AI systems understand and adapt to your unique preferences, right? In this case, it's recommending uh, cotton clothes, sustainable fashion clothes to the customer based on his preferences that the AI understood and stored from their previous interactions, right? That's part of memory. Creates a continuity across multiple interactions. So let's say that you go today to ChatGPT and you ask it hello there, and then it simply responds to you hello and then says your name. So my name is Prince in this case. So I say, if I go to on ChatGPT and say hello, it will respond back to me, hello Prince. So I saw this and I was like, wow, how did you know it was Prince? Right? That's another advantage of memory. They can understand things over time. So even if you start a new conversation or a fresh chat with this ChatGPT, it still knows that it's talking to Prince, or he or she is, or it is talking to Prince, whatever you might use, right? It knows that, or she or he knows that he's talking to Prince, or he or she is talking to Prince. I hope you get the point, right? So yeah, so memory definitions. Let's take a look at try to understand generators. Basically, a very generic understanding or definition of memory. So this is what I will say. Memory is our brain's capability from the humans, right? So I'm a human, right? So memory is our brain's remarkable ability to adapt, hold on to, and bring back experiences, knowledge, and skills like a personal library that helps us make sense of who we are and navigate what's ahead. So it helps us to develop a whole understanding of our society, what we are, who we are, what we know, understand our family. Like imagine you see your friend, you don't remember their name, right? That would be a weird existence. So memory helps us take care of all of that information. So you can store information like how I have a book to read, like me remember that hey, I have a book to read, which high school you went to, your high school graduation, how to make a pizza. It remembers all that. How do you remember all that? That's where memory comes in, right? So it just memory help us to understand all this and store information from a variety of perspective. So moving on to memory in context of LangGraph and AI agents. So let's go ahead and see what we have in here. So the major types of memory in AI systems are mainly two at the time of recording this video. Maybe in the future there'll be more. But at the time of recording this video, there are two of them. This is fairly a very new field, so a lot of development and research are coming out each time. So at the point of recording this video, from my research, there are only two. There is a thread memory scoped, a thread scope memory. That's actually a better way to put it. A thread scope memory, and which is also called a short-term memory. We also have a cross section or a cross thread memory or a long-term memory, also called a long-term memory, right? So thread scope meaning that it simply understand conversations within only one thread. What do I mean by that? Take just to give you a perspective. Imagine you are going on ChatGPT, right? And you click on the button to start a fresh chat. Anything you type within that chat is within one session, and the AI can recall. Like if you ask it, what was my previous question? It can recall the previous question only within that chat. But if you start a different chat in a different window or browser and you ask it, what was my previous question? It won't be able to recall, right? So those two chats are separated differently. So it can only recall information on the current chat, right? It can't recall information across multiple chats. That's one. That's basically what a short-term memory or a thread scope memory is in LangGraph or agentic systems. So moving on to cross-section memory. So cross-section memory basically this simply means that AI can understand memory across different sessions. Like let's say that you open one browser and the AI ChatGPT knows that hey, he's talking to Prince. If you open another browser in your phone or on another section, another window of your laptop, it will still know that it's Prince, right? So that is cross-section memory. It maintains the memory a whole information about Prince, right? No matter which session that Prince is using, it can recall that information. That is what we call a long-term memory. So it can recall information from Thursday's conversations, the last week's Thursday's conversation, last week Tuesday's conversation. You can recall all that information along with the current information. So that's a long-term memory, right? So in long-term memory, you don't store all the conversations. You only pick some information about the person that you store. Like if I'm talking to a human, right? I don't recall every word that the human said. I only pick some points to have a general understanding of the whole conversation, more like a summary, right? Or some important information. Like I don't go ahead knowing every detail about everyone, right? But I can tell you general information and very specific information that can help me classify or understand that person, right? That is long-term memory. So in the example of chatbots, in this case, we are talking about uh, the sales chatbot from Amazon. It doesn't really store in long time memory. It doesn't really store every conversation. That would be ridiculous to store all that information right in long term memory, right? Okay, you can do that, but it's not really that important, right? So what you can pick is a customer's preferences. What does this customer like? What are their favorite colors? What are their favorite brand of clothing? And all that. What are their favorite brands and stuff like that? So based on having that long-term memory about this customer, you can understand more about them and you can make better predictions in the long run instead of having to store every line of conversation. That's what the short-term memory does. So we leave that to the short-term memory. Okay, so let's understand the two difference between the long-term memory and the short-term memory. So let's start from or from scope. So we talk about the scope of a short-term memory is only within one session, one browser window, one conversation. Long-term memory is across multiple sessions, multiple windows, multiple chats, all that, right? Long-term memory. Example use cases can be used to keep track of what's going on or this being discussed, to handle pauses when someone takes a break or stuff like that. It can recall all that previous information within that session. Long-term memory saves and recall important information, details about someone's preferences, their past experiences, and very specific details that is needed for a long term. Right? I have a friend. I don't need to know every detail about my friend. I need to know general, very specific information. What's their name? Where does it come from? Where maybe where which school he went to, what is his profession, that kind of information, right? I don't know everything about his life. I have only certain details. So memory types is temporary memory, and then long-term memory is more permanent. LangGraph implements uses check pointers to implement short-term memory and uses what we call memory stores, which you look at to implement long-term memory. Okay. So memory in humans, let's try to understand long memory in humans. So we have understood what a long memory is, long-term memory. Now let's try to understand what long-term memory is in humans. So, so that's basically what you're trying to understand. It's very, very easy to understand. You just have to understand a couple of things. There are three main types of memory from more researches. There are semantic memory. So semantic memory basically stores factual information, basically your brain's factual database, like understanding equations, understanding physics laws, right? Like E equals to mc squared. That is a certain fact that you need to understand, like the vocabulary, meaning of words, historical dates and events, like when a country got independence and stuff like that. That's all factual information, and that's handled by the semantic memory. Again, this is talking about human memory. Then we also have episodic memory. So episodic memory simply remembers or stores events that are momentous, right? Momentous events in your life, like when you graduated from school. Um, Basically, it stores a biography about your life, right? When you graduated from school, your last summer's vacation where you went to, your first time riding a bicycle. Okay, oh my god, my first time riding a bicycle was really horrible. I still have the marks of the wound until today. So that's episodic memory, right? So we also have a procedural memory, and procedural memory stores instructions, right? How to behave, like how to drive a car, how to program. If you know how to program in Python, that's stored in procedural memory, right? So I will look at hold all this in terms of AI memory as well. So each memory type works differently to form your complete memory system. So you have the semantic memory, keeping track of your knowledge base, your database, factual information. Episodic memory, keeping important events, historical events or momentous events in your life, when you got married, when you graduated from high school, the first time riding a bicycle, the first time riding a car, and all that goes in there. And then you have procedural memory on how to basically a set of instructions on how to do things. How do you cook pizza? How to ride a bicycle? That can all be procedural memory, right? And then you also have memory in a long term. Let's now look at long term memory in agentic AI system. So you have looked at long term memory in terms of humans so far. Right now, let's look at it in terms of AI. What does all this come into play? So to really understand this, I really encourage you guys to read this paper. It's called the Koala paper. So what does Koala stands for? So Koala stands for Cognitive Architecture for Large Language Agents. Koala, so for short. It's a very interesting research paper, came out recently. I think came out last year, 2023, and it talked about how we can implement long-term memory in AI agentic systems and stuff like that, right? So, environment, observation, actions, cognitive language agent, and then you have see the memory base in there, and then all that. So, if you really want to understand this, you can take a look at Koala. But I'm just going to go ahead and simply give you a simple summary. So, semantic memory, basically, in terms of AI agents, can be stored in terms of lines like this information about someone. It's just a single document. You can be stored in multiple documents as well. So that's semantic memory. You can have stored in a single file like this. Like you can have preferences, which is a semantic memory, right? So all that information goes in there, right? So that's basically it. And then you also can have can also be stored in a list of documents, right? So yeah, basically the person's favorite food and stuff like that can all be stored in a list of stuff. So what's the difference between a single and a multiple file storage? So let's look at the description of it first. So single, one comprehensive document which stores all the information. Multiple, we have a collection of documents, and each document stores a piece of information. And then we have advantages, quick and easy to understand for single. For multiple, you can to see it can be difficult to manage and also to query, right? So this can be some of the advantages and disadvantages. Okay, so now let's look at episodic memory in terms of AI. So this basically stores the historic AI's history of AI's previous interactions and responses. Right, stores all those information inside of the episodic memory. We also have the procedural memory, which talks about instructions. So this is mostly focusing on system prompts, guide rails, and all that. All that goes into procedural. Like if you're writing a prompt to an AI agent, telling it, "Hey, you are an assistant agent working for X, Y, and Z. Answer the customer in this and this way. This is how you interact with the customer." All that is a system prompt. That goes under the procedural or instruction memory. Now let's look at the basically everything in summary. So semantic memory stores the history of facts. Okay. Episodic memory stores previous conversations, and then we have procedural memory, which is basically the system prompts and other things telling the AI how to work in the system, or how to behave and how to act. Right. Awesome. So once we have those in there, now let's look at the times to update memory. So right, it's like I said, let's talk about. I mean, a good example is use uh okay, I can use both. Let's start from long-term memory. So long-term memory only stores some information about a person, like their preferences, their favorite colors, the name of their mom, their favorite food. You can store all that in a long-term memory, right? But every time the AI is having a conversation with the user, it's not always mentioning those things. There are only some specific points in moments where the user talks about those things specifically. So you shouldn't be updating your long-term memory with just any kind of information. You are looking for a specific information, right? So you wait for that information to come in. Like if you're having a random conversation with the user and the user mentioned, "Oh, you know what? I like red. Red is my favorite color." That is when you need to update the long-term memory. You don't just update the long-term memory anytime, right? That's one example. From the point of short-term memory, whenever the conversation is going on between the user and the AI system, right? There can be a lot of conversations, right? And you can if you have worked with LLMs long enough, we have this thing called a context window limit. You can put any amount of information with the context window. It has a limit, right? If you go on ChatGPT and copy a whole book and try to drop it in there, it will tell you that you have exceeded the limit sometimes, right? If the text is too large. So there is a limit. You can keep the history of, let's say that the user has been chatting with this AI system from morning till evening. That's a whole lot of conversations. That's a whole book, in fact, or two books. You can fit all of that into contextual memory at this point. Okay, maybe in the future they can be some much larger ones, but again, even at the moment, they are very large context windows. But uh, there are different issues. If you put too much information in there, the AI can get lost and forget some information, like getting lost in the middle kind of issue. So the best thing to do is to always create a summary or filter your conversations in order to update your short-term memory, right? So if you have so many conversations with an AI agents and you go back to the past and you ask it the very first question, it might not remember because it's just summarizing the conversations, right? And trying to have a general kind of understanding, not a specific kind of thing. Even humans, right? If you have a conversation with me long time and you ask me, "Hey, what was the first word I said?" I probably wouldn't remember, right? Good. So moving on to that, these are the points. This is where it's very important to you pick which time or how you update your memory. So the first one is hot path updates. So the memory is updated while chat goes on, and mostly the user is notified. For example, if you're chatting with ChatGPT or Claude, if you sometimes can see saying, "Hey, updating memory" or something like that, that is hot path update. It's basically telling you that it's updating memory. So it does that within every conversation, right? So for example, you're checking the user and you want to store the user's preferences or their colors, their favorite colors, and the user mentioned, "Hey, my favorite color is blue." So now you have to go ahead and update the memory. So you can let the user know that's hot path, and then update memory that way. Another one is you can do it in the background, which is called the background update. Basically, maybe after every 10 minutes, you do some summary and update some long-term memory. Most of the time the user might not be aware of what's going on during this time. So hot path updates can be shown. For example, on ChatGPT, sometimes you can see it's telling you, hey, it's updating its memory. That's a hot path update. And then a background update happens in the background without mostly the user not knowing most of the time. So that's basically it. And these are the advantages and disadvantages of the two methods. So real-time processing, basically that's the hot. Sorry for that. That's my phone there. So let's push that aside. So the real-time memory, real-time processing, like this is a hot path update. Things happen real time, right? So the benefit is users' memory. Users can see the memory. For example, if you go on ChatGPT, sometimes you can see that information being updated. Challenge maybe may slow down the whole system or the response time because you're trying to do two things at the same time, chat and keep track of memory. So for example, on ChatGPT, you can see ChatGPT, you can see it's updating memory, and then finally continue with the conversation. That can be a bit of slow. And then some people might not like that, right? Some people might be, hey, I want to actually see what's going on, what's information is they updating, what's OpenAI collecting information about me, right? I want to see what's going on. Yeah, so that's also an advantage. Background processes updates happens separately, separate thread. So you can have a separate thread of your application. So the chat goes on, and then there's maybe another server somewhere or another thing, another thread on your application that is updating the memory. So the chat is not interacted. Smoother chat experience without any delays, right? Because there are two different threads, one handling the chats, another one handling the memory update, which maybe runs after every 10 minutes. So challenges is that needs careful timing of when to update memory. So you don't just update memory anytime. You have to be careful of the time that you update the memory. So it can be the two difference between those two methods. So we have reached the end here, and I want you guys to know what are your thoughts on the memory. For me, I think is right now there are so many generic AI systems, right? So every day there are new models coming out. All the AI systems have been learning a ton of information from online, but it's difficult for them to personalize to one individual person, right? And I think that to be the game changer, right? So companies, organizations that can create AI systems that are personalized to each individual user, right? Knows about your birthday, knows about your favorite food, can keep you company. What's your favorite sports? What do you like to talk about? It knows all that. That's more interesting to talk to or a chatbot to engage in than a very generic system that knows all the knowledge, random knowledge in the world, but cannot fine tune to your specific needs, right? So yeah, so I think memory is gonna be a very big step. Instead of having to fine tune stuff, now you can introduce memory, and memory can take care of that along with the general knowledge that it learned from training data with the memory. It's going to be something really powerful and a game changer. So yeah, that's all for this video, guys. In the next video, we're going to look at a practical coding section. We are going to go ahead and actually build a simple coding section with this, right? So we're going to take all this short-term memory, long-term memory, and try to build a customer support agent, and then try to integrate those things just to gain a very general understanding. So it's not gonna be very, very, very detailed, but I just wanted to gain a general understanding of what is long-term memory, what is short-term memory. Now that you've understood the theory behind it, how do we program a simple application to mimic that? Whatever you have discussed in this video, how do we create an application that can mimic that? That's where the next video is gonna go into. So guys, that's all from me. Thank you guys so much for watching, and if you enjoyed this video, one of the easiest way you can support the channel is just by liking this video, right? So like the video, share the video with your friends and family who might be interested in a common concept. So I'm just trying to go ahead and create a whole community online of AI enthusiasts where we all share, learn, and yeah, grow together basically. So you can also find me. I also write articles about these videos and stuff like that. So in this video, there's also an article for this video particularly. So if you're a person who is very, I want to read, I don't want like watching, then you can read the video, not watch. So you can read the article, right? You don't watch articles. Okay, so you can also find me on Medium at Prince Cramper where these articles are. You can find me on YouTube at Code with Prince, hopefully where you're watching this video. You can also find me on X, aka Twitter, at Prince with a capital P _ Cramper with a lowercase k. So you can find me on Twitter as that. If you have any questions, recommendations, get to me on those platforms. I'm much easier to respond to you on X and then on LinkedIn than email, right? So hit me on those platforms. If you have any project suggestions, you want us to build anything together, you did really need consultation on anything, you can always reach out to me on LinkedIn at Prince Cramper or LinkedIn Prince Cramper. Yeah, much faster to respond to you on LinkedIn as well compared to email. So guys, thank you so much for watching this video, and I hope you found this content helpful, and see you in the next one. And yeah, let's keep learning and let's keep growing together. Bye. See you guys.